Good morning, everyone, and welcome to Astronomy 100. Today is October 5th. We just came from our midterm yesterday.
Mr. B,
Yes.
it was my birthday Friday. I'm a young adult now. Can you believe it?
Okay. Happy birthday,
Thanks,
everybody.
sir.
Okay.
Happy birthday.
Okay. Anyway, so basically we just came from an exam, our midterm. Unfortunately, a few of you did not take it, which is kind of a problem. Now, let me tell you something, okay? Today I did not have a problem with the internet, but just in case if there is a problem with the internet, please don't leave, okay? So I will try to come back if in case I work out all the problems. But anyway, just came from a midterm. For the most part, everybody did well in it, which is good. And we still have quite a few more. I think we still have at least 2 more midterms that we have to go through. And we have basically covered all kinds of assignments up to this point. We covered basically a participation type assignments, namely quizzes and also discussion items. And we saw how that works. And a lot of you get the hang of it. And now they know basically how that works and participating and engaging in the class. The other thing that we did actually was the midterms. Now we know how they look like and we know what to expect next time around when they come in, which have a lot of weight. And that's why this week I really did not assign anything because of the fact that we had that midterm. So we had to really focus on it. I started last week with a new type of assignment. Of course, we had, homework also, which is kind of, which we're going to resume actually. Now that we're done with the midterm, we're going to go back to homework and we're going to go back to quizzes and other things. But in addition, we have a newcomer. We have the projects. It's saying that my internet is unstable, or the internet is unstable. I don't know if you are hearing me well or not. Anyway, we have projects. Projects are writing assignments, really. You have to follow the steps. You have to do them systematically. The biggest thing that you cannot do with a project that you may do with others is leave it to the last day and start working on them. They're long, sustained work. They cannot be done in one sitting. They cannot be assembled together and done correctly in one basically lapse of time. You really have to start on them working long term. The project that I posted last week, but it was not available until yesterday, was the Retrograde Motion. That is due October 23rd, this month. Today is the 5th. So technically we have less than about 2 weeks, slightly probably around 2 weeks to complete this, maybe a couple of days more than 2 weeks to complete that. That means we have to start working on it ASAP. Start doing this thing as soon as possible. We can, starting from this weekend. Then we have another project, the Lunar Project, and the Lunar Project is due November 20th, not this 20th, but a month from this 20th. So we still have more than a month. However, and this is a big warning, do not look at the deadline because there are steps that need to be completed starting from next week. The lunar observation requires that you go outside from your house or from your room at least, maybe the backyard, and look at the sky. Look at the night sky and look for the moon. Starting from Wednesday of next week, not tomorrow, but a week from tomorrow. You have to plan accordingly. You have to be outside of your room. You have to be in the open where you can look at the moon and find it. Record its shape, right? Basically how it looks like, and where it is in the sky. Not exactly, but approximately. And draw a picture of it and name the shape. So that's basically what the project is. You're gonna track it for 4 consecutive weeks. starting from next week, which is October 13th. Today is October 5th. Tomorrow, October 6th, a week from tomorrow, October 13th, you're going to be outside and doing a monitoring of the moon. Sometime at night, preferably around 9 o'clock, okay? 9 p.m. Then a week after that, which will put you on October 20th, you're going to do the same thing. That's the Wednesday after. You're going to be around the same time doing the same observations. A week after that week, which will put you on October 27th, that's another Wednesday, the last Wednesday of the month, you're going to go outside and do the similar observation and document it, okay? And the final observation is going to be on November 4th, almost a month from today. That's the last Wednesday that you're going to be doing your observations. That's the first Wednesday of November. You do not miss any of those days. If you do, there is no recovery for it. However, and this is only in the rarest of the occasions, if the weatherman tells you that, hey, listen, on the 13th, which is next Wednesday, there is a problem. There is too much clouds. There is rain coming. There is cloudy and forecast and all of that. Then check the 12th. So in other words, you also have to monitor the weather. Check the 12th. See if Tuesday of next week would work. If it is, then try Tuesday. If the weatherman said actually the weather starts from Tuesday and then going to Wednesday, then you're going to try Thursday, which will put you on October 14th. Really, the 13th is the day, and that is the day, even if the weatherman says that there is going to be a little bit of overcast, go outside anyway and look at the sky. You'll be surprised. Sometimes the clouds will open enough so that you can see exactly where the moon is and how it looks like. So those are the days you have to do your observations, okay? Now, this is a new type of assignment that we have never done before, and we have to know how to do them. We have to do them. There is a third project that I did not really include yet, but you should receive it hopefully early next week. And that project has to do with the stars. These two projects that I have introduced so far, and I'm going to go in a little bit more detail than this, have to do with the solar system. They both talk, one of them about the moon, observing the moon, and the other one is about the other planets, mainly Venus, Mars, Jupiter, Saturn, and also a dwarf planet series. So all of these objects for these two projects are for objects in the solar system, whether moons or dwarf planets or planets in the solar system. The last project is going to be on stars out there. So these are the three projects you're going to have in the class. So there are three projects, two of them already posted, one of them you should receive it soon. Now, in terms of requirements, you are required under any circumstance to do the observation for the moon and submit the lunar observation project. There is no question about that. That's part of your grade. You cannot avoid that. Now, the other two projects, you have some leeway. Here is the choices that you have. Either do the retrograde that is posted already, which I urge you to start on nonetheless, or do the stellar project, the star project, the project for the stars. One of the two you're going to do. You don't have to do both of them. You choose only one or the other. There is no choice in the lunar observation. That you must do. As a general rule, though, what you can do, you do all three of them. In Canvas, will account always the lunar project. That's going to be counted no matter what, but we'll take the highest of the other two projects. Okay, enough talk. Let's see exactly how this thing look like. So I'm going to share with you the screen. So this is the project from last week that I posted last week, but it was not available until yesterday. This is the project that was posted yesterday. You can clearly see that this is due October 23rd of this month, and it's worth 61 points. This project is due November 20th, which is next month, and it's worth 34 points. This is required. This you have to do. This one, you may or may not do, depending on how you feel about the other one. Okay, let's click on this one here. If you guys remember from last week, and I know we were in a hurry of the exam and all of that, and we probably missed this point, and I tried to go briefly on it. Nonetheless, when we clicked on it last week, it was not showing us this information. It was just showing us a rubric. And that is important. The rubric is a very important piece of the puzzle because it serves as a blueprint for doing the report, because it serves as a framework for actually doing the report. While I'm doing the report, I have to be mindful of this rubric. And when I'm doing the reporting, I have to actually follow the order. For example, I cannot put the conclusion in the beginning. That doesn't make sense. And I cannot put the objective toward the end. That doesn't make sense. I cannot take table, there are a bunch of tables. Table 3, for example, and put it in the front before table 2. That doesn't make sense. So try to stick to the order. Makes it easy for the grading, and it makes it easy for you preparing it, and it makes it easy for your reader, because the purpose of the project, or at least one of the objectives of the project, is for you to communicate your ideas, and you have to be mindful of the person who's going to be reading your report. So you have to stick to the order. You have to have a clean report, a nice report, well, basically a written report. And we're going to talk about what I mean by all of these things. So one of them is the order, which is really part of the organization of the actual report. So stick to this order, okay? Now, to help you in the process, there is a file in here, PDF file. This is a fillable PDF file that you really have to download on your computer and use, okay? If you don't like it, which is your right, or if it doesn't work for you, which might be a problem, you may skip it. As a matter of fact, it's not required, it's an optional. You may open Word and start working with a new document. When you do that, be in this order, follow the steps in here. Do not jump around. Do not make a report that does not look organized at all. So you have to organize it based on the rubric, okay? So that is not a requirement. Again, last week when I clicked on this one, it took me to the instructions, but I could not see it as a student because right now I'm logged in as a student. So if I see it, you see it. So I'm going to click on it to see exactly what this project is talking about. This project has several components in it. Some of them are drawing, like this one, like this one, like that one. Some of them are calculations. What the whole thing is trying to understand how planets move around the sun, really, and why do they exhibit this so-called retrograde motion, meaning at times they're moving in the same direction on the ecliptic, but other times they're moving back and then continuing backward, forward in their motion. Here is the deal. In this graph in here, what you have, these dots in here, 7 of them, are the background stars, the stars you see in the background. And somebody went and get you the data from July 10th of the year 2005, all the way to March 20th of the year 2006. So they went on July 10th, 2005, looked at the position of Mars, and accurately gave you the position in right ascension and declination. Right ascension is basically the circle divided in 24 hours instead of 360 degrees. And you have the 0 hours in the east, and then 1 hour, 2 hours, all the way until you come back 24 hours, you're back to where you started from. Okay? That's the right ascension. And degrees is actually how it is in terms of the horizon, where you see it. Okay? Now, based on this information, we're going to find the position of Mars, or we're going to draw the position of Mars. What you're given in here is a table. I mean, table, of course. You're given actually a graph. Graph is marked in hours. In the x-axis, you have 1 hour, 2 hour, 3 hour, 4 hour, 5 hours. Well, Mars moves around from 1 hour and 13 minutes, 1 hour, 37 minutes, 2 hours and 4 minutes, 2 hours and 42, 3 hours and 1 minute. And then it moves 3 hours. So at some point it was 3 hours and 26 minutes. Then it went back 3 hours and 24 minutes, 3 hours and 15 minutes, 3 hours, 2 hours and 47 minutes. And then it moved back to 4 hours and 57 minutes. In other words, it moved from 1 hour and 13 minutes all the way to 4 hours and 57 minutes on this axis. This axis is moving backward. Okay. Normally the x-axis moves this way. So this is 1 hour. This is 2 hours. We know there is 60 minutes in an hour. So this is 10 minutes after 1 hour, 1 p.m. This is 20 minutes, 30 minutes, 40 minutes, 50 minutes, 60 minutes would put me in the second hour, the next hour. So this is 1 hour and 10 minutes. This is 1 hour and 20 minutes. I have in here 1 hour and 13 minutes. 1 hour and 10, 1 hour and 20, 1 hour and 15 is midway. But this is not 1 hour and 15, it's slightly less than 1 hour and 15, it's 1 hour and 13 minutes. Here is the number, 1 hour and 13 minutes, should put it right in here. And I have to draw a line with a pencil all the way through from top to bottom to mark 1 hour and 13 minutes with a pencil. Do not use a pen. Okay? So this is 1 hour and 13 minutes. I have to locate 4 degrees and 54 minutes. 4 degrees and 54 minutes. I have 0 degree, 5 degree, 10 degree, 15 degree, 20 degree, and 25 degrees. I need to find 4 degrees. Well, this is 5 degrees. This is 1, 2, 3, 4. And 54 minutes, 54 minutes is almost a 5 degree. So this is actually 54 minutes, somewhere in here, this line. So I'm going to draw a line with a pencil all the way across. Where these two lines meet is where Mars was on that day of July 10th of the year 2005. So I know exactly where it was. I'm going to do the same thing for July 20th of the year 2000. However, the position is 1 hour and 37 minutes and 7 degrees and 9 minutes. Okay, 1 hour and 37 minutes. So this is 1 hour and 10, but this is 1 hour and 20. This is 1 hour and 30. This is 1 hour and 40. 37 degrees is somewhere in here. So again, with a pencil, I'm going to draw a whole line. And then I have to find 7 degrees and 9 minutes. This is 5 degrees, 6 degrees, 7 degrees, and 9 minutes is slightly above 7 degrees. I'm going to draw a line with a pencil, extending all the way across. Where the two lines meet, which is somewhere in here, is the position of Mars on July 10th of the year 2005. So this is July 10th, and this is July 20th. I'm going to continue August 1st, August 10th, August 20th, and track the position of Mars. And then I will see that it actually moves backward and continue forward. So this is part of the project. Of course, I plan to meet on Thursday, this Thursday, October 7th at 9 a.m. And you're actually invited to go in more detail about this one in here and how to do the actual drawing and so on and so forth. Okay, so this is part 1. Part 2, and I know I discussed this last time, is so this is how Mars would look like throughout this period, throughout the background stars in here. And in here, we're going to do the same thing, how Mars looks like versus the background stars. But from the vantage point of the Earth using the geocentric model, where the Earth is the center of the model. For me, I'm sitting on Earth, I'm looking at Mars. Here it is, how it looks like. If I draw a line in here versus the background star, so I mark 1 in here next to it. looks like it's in this position versus the background stars. If I take a line from Earth and extend it to planet Mars when it says in position 2, and extend that line until it meets the screen, then I know how it looks like versus the background star. So it was here, now it moved in here. And I continue doing this lines, and then labeling. You will see that Mars looks like it at some point it's moving backward and forward. So that explains the retrograde motion of Mars. So this is the geocentric model with the circles around, the circles going around, explains the retrograde motion of Mars, which somebody actually did. This is actual observations, and this is a model only. This is somebody trying to explain what you have seen. This is somebody has seen these observations and collected it and showed it to you and you plotted it. This is you trying to interpret it using the Earth at the center of the solar system and how Mars will actually move. Somebody else says, you know what? Earth is not the center of the solar system. Actually, the sun is. This is the heliocentric model. Well, if that's the case and the Earth is moving much faster than Mars, then I can, from Earth, I can look at Mars in this position and do the projection. It looks like it's in here versus the background star. If the Earth moves and Mars moves, then it looks like it has moved this way, at least versus the background stars, and so on and so forth. So if I connect from 3 to 3, 4 to 4, 5 to 5, 6 to 6, 7 to 7, I will see and label the numbers in here from 1 to 9, I will see Mars actually moving backward and forward. So again, I have a retrograde motion. So both models explain a retrograde motion, what this person has actually observed. Now, the final step, which is to actually use this model to make predictions, what's going to happen in the future. So you do the calculations using this formula, which is given to you. And we're going to go in depth on Thursday when we meet on it. And you record the numbers in here in months. And you add this month to this month. You're going to tell me when it's going to happen next time. And when it's going to happen next time. For the next time when it's going to go in retrograde motion and so on and so forth. And you're going to report your data. Obviously, the conclusion has to do with the fact that we use scientific method to prove that the sun is actually in the center of the solar system and the retrograde motion, and here trying to explain it with this Kepler's laws and everything else. So that's really in a nutshell what the project is. As I said, we will meet on this Thursday. The invitations are already basically planned. You will not receive the invitation until Thursday at 8 a.m. Because what happened out of experience is if I send a message early, too early, it's going to get buried down in the messaging system. And you probably on that day, you would be looking for it, hunting for it, and you don't find it. So I leave it to Thursday so that you guys see in detail, so that you're going to, so that on Thursday, the message will be right on the top, if not the toppest message, so that it's easy for you to find it. So we're going to meet on Thursday to go through this one in more depth. Okay, and answer those questions, because honestly, there were some questions in here that we actually needed to answer too. And you're going to be graded on them. So there was question 4, question 5, question 6, there are a bunch of questions in here that we need to answer in 1 and 2 and 3, which I didn't need to skip, but they are actually there too. And a bunch of other questions, and we need to know what we need to do on this project. Okay, so that's one. Let's go to the next one. The second project is the lunar observation. If I click on it now, it's telling me it's available yesterday, but the point in here, it's due November 20th. Okay, and as before, you have a rubric in here to help you with your report. But the main thing in here about this object, this project, in addition to the fact that you have a bunch of other questions also that you need to answer, you have to observe these dates. You cannot skip those dates. October 13th, October 20th, October 27th, and November 4th. Those you have to go outside and do your observations. So again, let me click on this. This is a Word file. So I'm going to download the Word file. It's a good idea you download it. Do not open it with the browser, and I will explain why. So I'm going to download it and open it with the browser, and let me stop sharing that screen to show you what happens when you do that, at least with my browser. Well, my browser is telling me, okay, you downloaded the file successfully, and this is how it looks like. I can see everything in it. Can I write anything in here? I'm going to write anything in here. I can't write anything. The reason why is because in here, I did not enable editing. Protected, be careful, files from the end. Please trust this file. So I'm going to enable editing. Now I can get into it. I can change it. Because if I'm going to use this one as a reporting file for me, that's fine. I can do that. The first thing is asking me to put the name. If I click on the name, nothing happens. I really have to double click on the name. Now I can put my name in there. Then once I'm done in here, and if I'm going to read, everything is great right now. So if I'm going to answer any of these questions, I have to double click again to get into it. So I'm going to double click and it takes me to the question. Now I can answer. I can put whatever I write in here, okay? So it's going to simply start typing. Okay, let's see what this thing is saying now. And again, when we meet on Thursday, we're going to spend more time on these two projects, including this one. Let's talk about the moon phases and how the moon look like, and trying to explain based on the position of the sun on one side, the earth is on the other, and the moon moves around, and as it moves, it spins, and different phases will form, and so on and so forth, and may even have to look at the book in here. But then I have to answer this question. And the same thing, I have to basically draw pictures in here. Whatever happens in here, do not Google pictures and upload pictures from Google or somewhere else. You have to actually do your own drawing. One way or the other, you have to do it either by pencil and pen, or pencil and paper, and then take a picture and upload the picture if you choose to, or you can use electronic drawing devices, like tools, like for example, if you're proficient with Paint, use Paint or whatever drawing tool that you have, but it has to be done by you. Okay, so this is this part. And now the observations, the actual observation. Again, it's asking you to put the position approximately. You're not going to give me accurate positions in here because you don't probably have the right tools for it. But what you can do is tell me, hey, it's on the north side, or it's on the south side, southeast, or southwest, or something along the positions roughly, okay? A little above the horizon, or well above the horizon, or somewhere middle in the sky, or something on that day, which is October 13th. It's putting October 13th, but it's asking you for the date. The reason why I'm doing that is because you may have a different date. It could be October 12th or October 14th, but you cannot wander too far away from this date. If it is this date, which is preferable, then you put this date. Then you're going to tell me the time you went outside and did these observations. I'm hoping for around 9 p.m. It doesn't have to be exactly 9 p.m. It could be 9:05, could be 9:17, whatever time you happen to be outside, but you need to document the time. And then the shape of the moon, is it a full moon? Is it a quarter moon? Is it whatever, a half moon? How does it look like, basically, the moon to you? Then you have to name the phase. Because based also on the shape, is it the lit is pointing toward the east or the west? That depends, of course, on the time of the month for the lunar month. And also in here, you're going to name that moon. Is it crescent, gibbous, waning? Is it full moon? Is it basically whatever you think the shape of the moon is based on your observations? And you're going to actually do a drawing either by hand or by electronic format also. So that's it. And then you're going to document your conclusion, and that's the whole project really for it. So this is really a straightforward project, honestly, and we can probably discuss it more next time around. And the biggest thing is going to be about these questions and what to put in them. So again, we're meeting this Thursday at 9 a.m. to go through these projects and what it entails in terms of how we're going to put them, the answers and the questions and things like that, and the verbiage we're looking for, how to communicate your ideas and how to put them together and get them organized and submit your projects, both of them. One of them is due soon, so we have to really start on it. And the other one, albeit is due later, but it still has to be started next week. In any other shape, you have to document the information and get it so that you're going to submit your report. Okay, So those are the two projects so far that we have in hand. Again, we're meeting this Thursday. The invitations will not be sent until Thursday morning at 8 a.m., but we will meet at 9 a.m. The meeting is planned for at least 1 hour, potentially 2 hours. I really don't like the meeting to be any longer than that because it becomes a little bit of it loses basically purpose and it starts to be too repetitive and does not really benefit that much. Oh man, what is this siren in here? So, as an item of discussion today is, you are really required to attend either live or recorded. Because of either case, you have to do it, okay? Live or recorded, the Thursday session to do projects. Okay, put it in your own word. You don't have to put it the way that I put it, okay? You may choose different ways of saying it, but the bottom line is, this is what I want to see, so that we are going to meet on Thursday. Either you attend live, which is preferable, because you might have questions that otherwise cannot be addressed, and we will meet for a minimum of 1 hour. We'll go through both projects basically in detail, answer all the questions, make sure that you know what you're doing, and also make sure that the reports, I'm going to publish actually a rubric, I'm going to share it with you guys on how to do the actual writing, to make sure that you do a little bit of, be mindful of how you communicate your ideas in science, because part of the process in the scientific process is, yes, you go and collect data. Yes, you come up with a model to express, or theory to express that data. Yes, you make predictions based on those models. Yes, you go and do other observations. But part of the process actually, and it's a key part of it, is to communicate your findings in a clear fashion that people can understand it, or at least the peers can understand it. So you have to be accurate. You cannot make up things that are not there. You cannot ignore things that are out there. So it has to be accuracy is a key thing in here, okay? Which means that the verbiage or the writing has to be correct. So there is a proper tense for it. There is a way of expressing it that I'm going to share with you on Thursday to make sure that this is done right. Does this sound like it's a good plan?
Sounds good.
Okay, very good. So let me stop share. Oh, I stopped it already, but let me make sure I go back into screen where we were. And let me share the screen. Okay. So let me go back home in here. Again, this is the stuff from last time and this time. And because of the importance, I really had to go through it. The rest is typical stuff. We have the objectives for this week. We have also the review from the previous week. We have the discussion that is going to be posted in there. One of the items I already posted for you guys. You can choose that one or put it in your own words. And then we have Unit 41, and then we have the project. We don't have any quizzes. We don't have any homework, but I promise you're going to have some more down the road starting from next week, okay? So that's it. You're exposed to all kinds of assessment that you're going to have in this class, no more, okay? Now, as usual, we'll go into the objectives to make sure that we're on the same page everywhere. And the first part of the objective is what I was talking about, the projects. I made a big fuss over them. And that is important because they actually occupy a good chunk of your grade too. So we have to really make sure that we do them right, okay? So this is the first part that we were talking about. Now, the topic of the week is on Venus, planet Venus. That's what Unit 41 is. So let me put it in context so that we know exactly where things sit. Okay. So far, we learned about planet Earth, Earth as a planet, really. And that was useful for us because of the fact that we projected what we know about Earth to other planets in the solar system. Why Earth and why we did not start with something else is because Earth is actually within our grasp, within our reach. We can test it, we can sample it, we can observe it, we can do all kinds of measurements that we cannot do with other objects, or at least there is accessible than other objects. And we know a lot about it. We don't know everything, we still are learning, and we are still updating our knowledge about it, but that serves as a model starting point for the rest of the planets in the solar system and objects elsewhere. Obviously, the next object we moved on, we took it and projected it on the moon. It turns out what we learn about the Earth is useful. It teaches us about terrestrial planets, like, for example, Mars, like Venus, like Mercury, and actually it taught us also about the moon. So when we looked at the moon, we took from what we understood about the Earth and we projected on it, and it turns out to have good, useful information that matched what we already came up with in terms of models, and it worked in terms of structure, in terms of, we don't know everything about the moon yet. I mean, that's an ongoing process, as we're talking about, just as much as we don't know everything about Earth, which is, like I said, accessible. So this is something that that's part of the scientific process that we do in science. Earth actually taught us something else too. When we looked at its atmosphere, it turns out to have some useful info that we took from there and basically projected it into some of the planets that are actually mainly gas, like, for example, the gas giants and things like that. So we want to explore that and see how that will take us. The next object after the Earth and the Moon is the closest object to the Earth in terms of distance, side by side. If you take everything and put them on the side next to Earth, of course, forget about the moon because it's too close. The closest object is actually Venus. It's much closer than Mars is. Okay? It's not just that. Venus has a particular interest to us as a planet. It is almost the same size as the Earth. Very small difference between the two in terms of size. Physical size, that is, radius, diameter, or circumference, if you wish, or volume. All of them, they are very close from one another. That's one thing. In terms of mass, they are not too different either. Venus is very close from the mass of the Earth. So it looks similar, both in size and in mass. Furthermore, in terms of gravity, the force of gravity, the weight, is almost the same. So if you happen to stand, and if you could stand on the surface of Venus, you're going to feel the same weight as if somebody blindfold you and then tell you open your eyes. You wouldn't notice probably that you lost a little bit of weight because it's slightly less than the weight of the gravity on the Earth, but that's almost the same thing. And like the moon, which when you lift your hand, you start jumping. So it's a completely different for gravity, or even Mars, okay? There's a lot less gravity. So that is one thing that is similar to the Earth, to the point that it was dubbed the sister planet of the Earth, or the twin planet of the Earth, because of a lot of similarities. But that's almost where the extent of the similarities end. Venus, when it comes to the atmosphere, has a far, far, far more atmosphere than the Earth does. The pressure on the surface of Venus is so high, it's about 92 times that of the pressure on the Earth, that if you were to stand on the surface, you will be crushed just by the weight of the air above you. As a matter of fact, the weight on the surface of the Earth, I mean, the surface of the air, the atmosphere of Venus, right above the surface, does not really behave like a gas at all. It behaves more like a liquid, more like an ocean, more like liquid, basically, because it's so thick. That's one thing. The other problem also with the atmosphere of Venus is its constitution, its basically composition. It's not made up of the same stuff as that of the atmosphere of the Earth. The atmosphere of the Earth is mainly nitrogen with oxygen, with some oxygen in it and traces of other elements. The atmosphere of Venus is mainly carbon dioxide with some sulfuric acid in it and other elements, traces of other elements. This is a big, big difference. It's a thick atmosphere, carbon dioxide mainly. So what happened? Why are they so different when it comes to the atmosphere? That's one of the key things that we wanted to understand about the planet itself. As a matter of fact, the atmosphere is so thick that the planet reflects a lot of the radiation from the sun as it hits its surface. I mean, it's an upper atmosphere. It's reflected backward to the point that it's so bright. The planet is very, very bright. If you look at the night sky, this is the brightest object after the moon at night. People took notice of this one in the old days because immediately after the sun sets, they see this bright object in the sky. And before the sun rises, they see this object in the sky too, so bright. They gave it a name, the morning star, and the evening star turns out to be the same star, which is really Venus in this case. So it has these properties in here. For the most part, it's a reflective planet. I mean, the upper atmosphere reflects most of the radiation. Nothing penetrates. If you were to stand on the surface and look for the sun, it's very hazy every which way you look, and you're hardly going to notice that the sun is going to be out there, day or night. Okay, so this is part of the properties of this planet. Furthermore, the surface is hot. And when I say hot, it's super hot. 870 Kelvin. That's too much temperature for most of the materials. As a matter of fact, iron at that temperature, lead at that temperature melts. So it's above the melting point of lead. No electronics could survive that long on that under those tremendous temperatures and also pressures. So any exploration for the planet by the Russians, for example, and here the picture that you see before you, could not last for a long time, probably maybe at best an hour or so, okay? So that is part of the terrain. Actually, can you see that is baked under tremendous temperatures and tremendous also pressures, and also the rain. There is sulfuric acid that rains on a regular basis on the planet. So this is not an environment that is, this is a hostile environment for life as we know it. So this is not something that you would want to be anywhere near it. You cannot stand on the surface. There is no way. We don't have enough material strong enough to, in the same time, can basically sustain the temperatures and the pressures and the different conditions on the surface. So this is basically how the planet is. It presents itself to us. In terms of topology, or in terms of geology, if you wish, the surface looks, at least it has also high lands and low lands. Do not confuse those blue colors with the oceans. It looks like it has oceans. It may have had oceans, and actually there is modern studies that shows that it did have oceans in the past, okay? Not too long ago though, about 150 million years ago, anywhere between 150 million to about 450 to 500 million years ago, the planet actually did not look too different from Earth. It had oceans, albeit probably shallow oceans, and it had also highlands, which look more like lands on the surface. So that's basically how the planet looked like. It may even have harbored some sort of life forms on its surface. Something happened to the planet, though, after that, where huge eruptions, volcanic activity every which way, And I urge you to go through the unit itself to see the different kinds of volcanic activities that we can actually depict right now. Erupted in the planet. What they did, those eruptions actually, they released carbon dioxide. So the planet must be hot inside, and it should, because it's the same size of the Earth. So whatever process, which is a radioactive process that is causing the Earth to heat up inside, is the same thing causing also Venus to do the same thing. But the planet really needed to get rid of that excess heat, and the best way to do it is probably through the volcanic activity. Why did not do it before, or at least with that much intensity? Why so many volcanoes erupted around that time? This is one of the mysteries that scientists are trying to solve right now. What caused it? Was it an internal process, or was it something that hit it from outside and triggered the process and started it? Once the process somehow started, the planet went through a big, basically, process where it lost its oceans. So the carbon dioxide that was released was trapped in the air because there is no way for it to get rid of it, to recycle it. And that carbon dioxide, basically what it did, it caused the surface to heat up because of the fact that the greenhouse effect. Now, the radiation is still coming from the sun at that time, going into the surface, absorbed by the surface heats up and emits backward infrared radiation. That infrared radiation is basically trapped by the carbon dioxide and sent back inward. The temperature increases, which causes the water to start to evaporate, where the water itself, the water vapor itself, also is a greenhouse effect gas, in a sense that it also does the same thing. So it's going to absorb the infrared radiation that is reflected back from the surface and push it back, and that heat, which is really the heat, causes the temperature to increase even further, causing more oceans to boil, more water to boil, causing the process to increase, and you still have an outgassing from this volcanic activity that continuously dump carbon dioxide, which mixes with the oxygen that was released from the evaporated water. That evaporated water now sitting at higher temperature breaks down. Part of its oxygen combines with the carbon to form carbon dioxide, increasing the process even further. And part of the problem is that the temperature is getting so high that these gases are moving so fast, and that's what basically drives the weather actually on the planet, or the atmosphere on the planet. Now, hydrogen also, that was part of one of the byproducts of the dissociation of the water, gains a lot of energy, just like everybody else, moving extremely fast, but because it's lighter, moves upward in the atmosphere, but because it has very little mass, its weight is less, so it's going to escape with very little velocity compared to the others, and it's lost forever. The planet continued in this process. It lost all of its oceans, continued to put more stuff in the atmosphere, causing more heat. But then at some point there was a saturation in the atmosphere, which still to this day is being basically replenished. But in terms of gases, in terms of radiation penetrating through the surface, basically it reached the limit. There is no more penetrating. That's why the planet have very high reflection coefficient. It looks so bright. So the heat that is inside is trapped now, and it's really in an equilibrium state at this point. Basically, everything is internal, the process, and the planet basically went through this whole thing. In terms of geology, as I was saying, it's marked with this highlands and lowlands. One of the biggest difference in here that we couldn't figure it out, and must have been true, and it's actually we couldn't figure out the cause for it. It's not made up of different plates. It's only one plate. The entire crust is only one basically structure. Because part of the reason why the carbon dioxide is actually recycled on Earth is because we have plates, and the plates rub against one another. One of them goes through by the process of subduction in another plate, taking with it the carbon and basically recycling it back to underneath the surface and hiding it. And basically the planet is getting rid of that excess carbon. The problem with it in the past, it was fine. The Earth was getting rid of the carbon as fast as probably is going, as fast as it's made up, or at least produced. And the process was a cycle basically for the carbon that it goes to, in some sort of a balance. Nowadays, due to human activity, we're putting more carbon in the atmosphere than what the Earth can get rid of. So we're actually going through a similar process right now. The Earth is putting more carbon in the atmosphere than it can handle. In a sense, we're actually going through a greenhouse effect right now, just as the planet did go in it in the past, how Venus did go through it. But the problem with Venus, it did not have a way of getting rid of the excess carbon. So that's probably the biggest difference between the two, and that is the biggest difference in terms of the crust, of how it's formed. In terms of the mantle, there must be also a mantle, which is super thick, as thick probably as that of the Earth. Again, we're speculating at this point because we really don't have a lot of data. And then we have the core, which has the solid core inside, and also the molten part of it, which is the upper one, which is under tremendous pressures and temperatures, because of the heat that is generated from processes, the radioactivity. And that is the same composition, nickel and iron. And nickel and iron are metals, which means that we have a lot of free electrons floating inside the core that potentially could form a current. But the motion there is more random. It's not in one direction or the other, because the planet spins extremely slow around its axis, this way, clockwise. Planet still goes around the sun counterclockwise, like everybody else, but in its own axis is going clockwise, how the clock goes, from noon to 1 to 2 to 3. That is basically the type of motion that you have. In other words, the sun rises on the planet from the west and sets in the east every day, except the day there is extremely slow. It takes 243 days to go once around its own axis. So the day is extremely slow. That slow motion does not drive enough current in the core to cause magnetic field. That's why the planet did not have a magnetic field. The magnetic field on Earth is extremely important to protect its atmosphere, actually, otherwise we will lose it, to protect the life actually underneath from the fast moving particles that are ejected by the sun from the corona, and also from cosmic rays. And the magnetic field, first of all, serves as a shield to direct all of these particles outside for the most part, or to the North Pole or the South Pole in the case when they come to the Earth. But on the planet Venus, it does not have a magnetic field, and the slow motion is a culprit in here. It's not because it doesn't have enough material to heat up the iron core and the nickel core that it has. So this is some of the things that we know about the planet, about its shape, about its topology. One of the key features about Venus is most of the terrain in here is named after famous women, whether women in history or women in mythology, with the exception of this mountain that is made out of Maxwell. So, but this is basically the main features. This is the main things about the planet. One of the things that we learn from this process is key in here, of trying to think about it. We have to think about it. Is the fact that here we have 3 examples of planets in the region where water could exist in liquid form. Mars, Earth, and Venus. Out of these 3 projects, 3 planets, only the Earth has liquid water today. Mars could not have liquid water in it. If you put water on the surface, it's going to evaporate because of very low pressure, very little atmosphere. So the boiling temperature for water there is so low, so it lost all of its oceans because of the low pressure in there. Venus went through a greenhouse effect, basically, that accelerated its, accelerated. In doing so, all of the oceans boiled, and basically the water was lost completely. Part of the composition is gone. The hydrogen is lost in the process. And the Earth retained its water form. All of these 3, they should have water in the liquid form. When we're looking for exoplanets outside of the solar system, we are always looking in a region around the star where water could exist in the liquid form. In other words, the temperature is not too high or too low. If it is too high when the planet is close from the sun or from the star, then the water will boil. If the planet is too far, like for example, Jupiter, the water will freeze. So there is a region where the water could exist in a liquid form. And that region is where we should really look for planets that could harbor life as we know it, because the water cycle is critical for life forms. Now, on this solar system, we have 3 objects, 3 planets basically that exist in that region, and only one of them was successful enough to retain its water. So which means that when we look at different stars, we have to be careful with this assumption. The fact that we find a planet in this zone, which is they call it the Goldilocks zone, does not necessarily mean that there is life form on it. There are other signatures of life that we really have to hunt for, other than just the fact that the planet is there. Because we have 3 examples in here, and only 1/3 of them was successful enough to retain its water. So that is basically some of the things that we have to look for. Always when we are thinking from our vantage point as humans, we look into, because when Mars was first of all looked at up close with telescopes, people thought that there are canals in there, and the Martians are building canals on this desert planet that they're trying to drag water. Now we know that they're not canals, but they're runaway water from the old past. Also, when they looked at Mars and they saw that, Venus, when they saw that thick atmosphere and the Venus is in the right place, so they theorized, hey, maybe there are oceans in there, and maybe there are lands in there, maybe there are trees in there, maybe there is even life, maybe there are some life forms in there, probably dinosaurs are still living in there, and people thought that we can go and basically look at the different forms. It turns out that it's far from the truth in either case. So always we tend to think from our vantage point to see that there is a condition for ourselves, and it turns out there are other things. So we have to really, really, yes, okay, Paula. We have to really be careful of this. I'm answering the question on the discussion here. I have to really be careful on those things. Anyway, I don't want to go blabbering on these things. Let me go back into the home in here to make sure that we didn't miss anything from this week. So we have the 2 projects, and the item of the discussion, as duly mentioned, has to do with this project when we meet on Thursday. And this is the objective. The notes are in here, so please read the unit. It has far more info than what I just discussed. It has more details than what I just talked about. Like, for example, how did we know the surface, the radar technology that was used to penetrate the thick atmosphere and basically draw the topology of the surface. Okay. Of course, the discussion item is going to be here. This is the previous week. And next week, you will have more assignments, things like that. So it's good?
Yes, it sounds.
Okay, so I'm going to stop the recording, and I will see you guys on Thursday.